Bismillah ar-Rahman ar-Rahim, student. This is a paper, June 2025, 42 variant and complete mechanics paper. So let's try to do the question number one. What a question number one we have, if you look at carefully, a crate is being pushed, okay, straight horizontal surface by the force of 25 newtons. This applied force. And angle theta above the horizontal. So thing is, this is an object I just show you here. Is placed on the horizontal track and applied force is this way. If 25 newtons enacting how much angle? 20 degree above the horizontal. It means from horizontal, this is a horizontal line. So how much angle? 20 degree upwards. So naturally it has a two components, one act this way and one acts this way. This is a 20 degree. So this is a 25 cos 20 and this 25 sine 20. Okay, this is just extra knowledge, but read a question. Create move a distance of 12 meters. So this a distance given by 12 meters and time is how much? 8 seconds at a constant speed. A question comes constant speed. So constant speed means acceleration 0. And he asking for the constant speed for the crate. And what is the formula? Distance is equal to speed into time. And we are looking for the speed. And we have given distance is 12. Speed is unknown. And time is 8. So it becomes 12 by 8. So 4 threes are 4 twos are. So 1.5 meter per second. I hope so you understood well how I got this answer. And second number, he said constant speed. So that is why speed is not changing. I hope so this part is very clear. And let's go for the part number 2. What the part number 2 is asking for? Part number 2, work done by the 25 force newtons, 25 Newton force. So we'll find out the work done. Okay, students, what is the method to do it? You know, work done formula is what? Applied force into distance. But force, I will not take 25. No, not at all. We'll take 25 cos 20. And we can write it now here. 25 cos 20. And distance is given by him is 12. So if I check it and multiply, so answers turn to be what? Yeah, after rounding 3 SF, 282 joules. 3 SF work done by applied force. I hope so the point is very clear. And let's go for the next part. And next part is what? Find the power at which this 25 Newton is working. Power formula we have, basic formula power is work done by time. Work done, we just got it to 282. And time, we know it very well, given on top. So if I just put the value of, and that is a 282 and divided by how much time? 8 seconds. So if we check in calculator, just let me check, 282 divided by 8. It turns to be 35.3 watts. Okay. This is done. Alhamdulillah Rabbil Alameen. The question is completely over. Question number 2, students, we have two particles, P and Q. P mass is a 0.2. You can see Q mass 0.1. Are free to move in a straight line, a smooth friction not there. And P is thrown towards Q with a speed of 5. And the same instant Q is thrown away from P, a speed of 2. So let's have a plan with a particle. So copy and paste. Two particles. This is a P particle. This is a Q particle. Okay. P particle is 0.2 kg and Q particle is 0.1 kg. This is before collision, and let's talk about after collision. What is after collision? Okay. What is after collision? First of all, he is saying clearly that the P is moving, P is moving 5 speed. And Q is going away from P is a 2 speed of 2. And and they will P and Q will coalesce, it means they will behave like a one particle. So student, how I can write it? I will bring in one object. So this is a situation we have. Okay, and this is clear. And first of all, we can find the speed from here easily, combined speed, and then loss of kinetic energy we need to find. So what is the formula? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. But because VV are same, they are together. So VV same is 2, 2 and gone, common out. So we got a M1, M2 in the bracket and V outside. Now simple plug in the numbers. So mass 0.2 into 5 plus 0.1 into 2. And here 0.2 plus 0.1 times 2 V. And now just matter of the solving in the calculator. Okay. I got left side and divided by 0.3. My answer is coming 4 meter per second. Combined speed. But now he's asking loss in a kinetic energy. So I will find out kinetic energy before collision. This is a before collision, before collision of the whole system. So it means half mv square, half this mass, and second is this one. So half mv square, m5 square, m2 square. So I'm going to find it. So half into 0.2 into 25 plus half into 0.1 into 4. And I got a 2.7 joules. 2.7 joules. It is a kinetic energy before collision. I hope so. This part is very clear. Okay, now we'll talk about after collision. Okay, before collision is clear. Let's talk about after collision. After collision is kinetic energy after collision. So after collision, same formula, but this time both masses are same. I can say half into m. M is what? Just add them. And speed is what? You know, speed is 4. So when I check it in calculator, so it is half into 0.3 into 16, and I got an answer 2.4. So 2.4 joules. And how much loss? So loss is naturally, loss is 2.7 minus 2.4. And final answer is 0.3. Sorry for that. 2.4. So 0.3 joules is the answer of the whole concept. I hope so the idea of the question is clear. So question number 3 we have, if you read the question carefully, the mass is 5 m kilograms, so mass is m kilogram. Into 10, so this becomes 10 m. Okay, and the length is 2.6, mentioned clearly. Another end of string is a fix, okay, fine. And the particle equilibrium, all right. So, and 35 Newton force acting, okay, and this is a 90-degree, he said perpendicular, done. And further, he said string, tension string is T. So naturally, if this is a 35, and he help us, the tension string is T. Where is acting that one? I always give example, if a bucket of water is this, bucket of water someone is holding in hand. For example, this is arm. So weight act downwards and tension acts upwards. Tension always opposite to that part. So tension is where? So tension is not this way, wrong. Tension is opposite. So this is a tension. And what he said that further, and we can assume this angle as a theta. Okay, and this 2.4, so 2.4, 2.4, and 2.4. So I will make it as 2.4. This triangle I will extract and make separate. I repeat my words. This triangle you can see clearly. I'm going to make separate, okay. So when I make it separate, you can see here below. So this is a theta, and this is a 2.4. It's come from here. And this is a 2.6. And this is a 90 degree. So I can find easily opposite by hypotenuse. So sine theta, opposite over hypotenuse. So theta is turns to be what? Theta is sine inverse, and 24 by 26 we got a some answer, some angle, or I got 67.3801. Okay, this angle I got it. This angle I got it. Okay, now I'm going to find this angle as well. So one thing is very clear. If this is, let's say, theta, this theta. So how much this angle? 90 degree. How to get this angle? So this is turned to be 180 minus 90 minus this. So you got this one as a 90 minus theta. So what is this angle? This is the same. How come same? It means from 90 subtract. Look at here. This is what I show you once again. Once again, this is a 90 minus theta. This full 90. From 90 subtract that one. 90 minus theta. 90 cancel. We got a theta. So in this sense, this is a theta as well. So anyway, you can do it this way technique, or the by subtracting from 90. So this is very clear. This angle and this angle are 100% equal. So this part is very clear. And now I'm going to erase them, erase this line, and just want to show you. Okay, so this is our components are very clear. This component which acting upwards is and one acting here. So this is a theta. So this is 35 cos theta, and this 35 sine theta. And this is a tension. So this acting this way and this acting this way, because this is a tension force. So this is theta is here and here, same for your knowledge. Why? When two lines are parallel and this same. So that is why. So this point is clear. I can use it here. There's a t cos theta and there's a t sine theta. Now question is ready to solve. Now how to solve it? These two component acting equal to 10m. So I'm writing and this equal to that. Okay. So first of all, t cos theta is equal to 35 sine theta. Okay, I'm going to replace the values, or I can do one thing. This I can replace directly in the, I think we have both numbers. So no problem at all. And this cos will go under it. I can say this is a 35 tan theta. So rather than I type in calculator, I can plug in this complete value here and I can get the t value. And that is what value? Let me check. 10, and my answer is coming 35, and this turned to be 1205. I repeat, I did not type this much in calculator in the place. No. Full value, I mean answer, I will plug in it here. And I got this one. So it means 35 into 12 divided by 5. My answers turned to be 84. So 84 newtons, I got it without any work, extra working. Now, these two component is equal to this one. So I can write t sine theta. So t sine theta plus 35 cos theta and is equal to 10m. Okay, so I can replace all values now. So how we can replace? 84 comes in the place of t. 84 times to sine. This I type in look, I give a long number, and 35 times to cos 67.3801 equal to 10m. And after this 10 will divide, and I check in calculator. So when I type in calculator 84 times to sine 67.3801 and plus 35 times to cos 67.3801, and I got a 91. So 10m is equal to 91, sharp 91. 10 divide, I got 9.1 kg. So Alhamdulillah Rabbil Alameen. I hope so the concept of the question is completely clear. Question number 4, we have a car is traveling all along a horizontal straight horizontal road. Car passes through point A on a traveling speed of 15. Okay. at a speed is 15, then the accelerates uniformly at this acceleration and for 30 seconds. Okay, so in this sense, we have some data, and what's data? Starting speed will behave, this 15 will behave as a starting. Acceleration, we have 0.4, and time, we have 30 seconds. I can find out V easily, and how we can find? You know it very well. V is equal to U plus AT. So V, what is U? 15, acceleration 0.4 into 30. If I check in calculator, I get what answer? V is equals to 27. Okay, this is done. Now, read a statement. It means, okay, we got it. Then the car is then move with a constant speed for 3t seconds. Okay, situation is like this. So this is going this way, first of all, and 15 and 30. So 15, so it is slightly less, I think so. So this is a 30, and this is a 15, and this point is, what is this? Got a final speed? I think 27, I got it. Yeah, 27, I got it. Okay, and then we move a constant acceleration for how much time? For a 3t. So it means the time from here till here is 3t. Okay, and then decelerate and uniformly with a value 0.2 and a further t seconds. So it means, for your knowledge, again, I use the same data. V is equal to U plus AT. V is final velocity, is naturally, I don't know what is that velocity. Okay, we can find it. U is this 27 behave, because we are considering from here. So this is behaving as a starting speed. So starting speed 27, acceleration, I just got it, not acceleration, deceleration. And I can say negative 0.2 and this capital T. So it means final velocity we have, but I think there's no need. Okay, anyway, I just got what answer. So this is stop here, not stop, sorry, because reach at this. And what is said that sketch this one first of all. This is a 30. If you someone ask what is this parameter here, 30 plus 3t. So I'm writing here 30 plus 3t. And what is this number? So t more add, because this time is t. So 30 plus 40. So this much is sketching 2 marks for the diagram. This is done. So let's complete the lower part. He said total distance is 2750. It means area of the trapezium, area of rectangle, and trapezium all together is 2750. So what is this trapezium area? Or we can find, using this data, we can find S as well. So no issue at all. Trapezium area, or use the other formula. So we have two choices. So 2AS is equals to V squared minus U squared. So what is acceleration? You know 0.4, and 2 times 2, 0.4. S is a job to find. Final velocity is 27, and so starting velocity is 15. So we have a two ways, using a trapezium rule or this technique. So both techniques are applicable. So divided by 2 and divided by 0.4, and my answer is coming 630 meters. So this is 360 meters distance for the first trapezium. Second is a rectangle. What is the distance? So 3t into 3t. This gap is 3t, and this height is 27. So there's a second, there's S1. And how to get S2? S2 is a formula. Rectangle area, as you know, but this is 27 and the 3t. I got a 81. So if I multiply them, S2. So S2, I get what here? S2. So I got a 81t meters. Okay, this is also done. Now one last part left only. What is that? And that is a trapezium. Again, trapezium. Okay. So now I think so we need, yeah, this is a final velocity is helping us. So what we found before is a helping. 27 minus 0.2 capital T is the final velocity. Basically, this is a, okay, final velocity of this motion, we have it. Starting velocity of this motion, we have it. Deceleration, you have it. And what is X is equals to negative 0.2, whatever, we have it on the top. and we can find S easily. And we can use two techniques. Is a trapezium rule formula, just sake of for your knowledge, what does the trapezium rule formula have into H in the bracket A plus B? What is A? This is called A. This is called B. And the gap between them, which is capital T, is behaving a H. Just a knowledge for you. So I think I can work with the other formula, and formula is very clear. So I think I can do it because space may be a problem. So I can do it slightly up, and this I got it here. Okay, and I can find it now here. So last position, last part, I'm going to find. And what is that? S3. How to get S3, students? Okay, so S3. So S3 formula, if I use the trapezium or the other one. Other one formula is 2AS is equal to V squared minus U squared. And what is A? That is a negative 0.2. Let me check once again, negative 0.2. Yeah, negative 0.2. Yes, correct. And S is a task, S3. Final velocity I just got on top. There's a 27 minus 0.2 t. 27 minus this will create a problem maybe. So I think I can go for the that other formula is better, I think so, which can we save the time. This is not wrong even, it will take time only. That what is the formula? Trapezium area is equal to half into H. H is capital T and U plus V. U is 27 and V is I just got on top 27 minus 0.2 T. 27 minus 0.2 T. Okay, this is a S3. I got it. And I got it from here, T divided by 2. In the bracket, I got a 54 and minus 0.2 T. So now students add them all three things is equals to 2750. So I'm writing now 630 plus 81 T. And uh, this one I can just type in calculator. 54 divided by 2, I got a 2070. This is 2070. Okay. And what about this? If you divide 0.27 divided by 2, I get a negative 0 point. Sorry, this is a yeah. This T will, but just a minute, please. I think I did mistake here. This is a T, I think, not 7. This look like a 7. This is not a 7. This is a T. So I can get it now. This T. So it means I can get it now. What, students? It is turned to be negative 0 point, and 0.2 is cancelled. Divided by 2, I got a 0.1. 0.1 T to power 2. So is equals to how much distance? 2750. I repeat once again. Let me check. This is 2070, correct? Okay. I think all okay. Reorder. I'm writing in order. So I'm writing here T is 0.1 T to power 2. And this is okay. Or do one thing. Both choices are okay. I'm writing this, keep as it is, no change at all, negative 0.1 T to power 2. These two values, if I add them, I get a 7 plus 1, 8, and 108 capital T. And this will go there and subtract from there 630 minus 2750. And I got a negative 2120 is equal to. Now I'm going to apply quadratic formula, negative B plus and minus B square minus 4A, and C is negative 2120 over 2A. Okay, now I'm just getting the answer directly. So A is negative 0.1, B is 108, C is negative 2120. Okay. My first answer is coming with me. I'm getting 2 times. Time 1 is 1060. Second time getting 20. So this time ignore. I'm writing the word ignore here. And this is my answer. Logically, why not possible? Because huge time is not possible to get this kind of answer. So this part is over. And next page, part C, student, we have car continues its motion, its journey from B, decelerating uniformly 0.5 until it comes to rest at a point C. Okay, total distance we find. Okay, interesting part. We have to start apply formula from B to C, but distance we need to find A to C. Okay, so first of all, let's consider B to C. What is a very interesting part? What is a go back and show you. According to situation, if you look at carefully, he says point is A and point B. So point B is where? Point B is this the point B? This is a point B. And what is the last velocity at this moment? Okay, that is a very interesting. We will take as a U. So 1 minute, please. If I wait a minute. This we have a formula 227 minus 0.2 into what we have a down answer. We got it 20. So into 20. So you see, students, look at now. If I plug in that 20 value, which 20 value you talk about? This 20 value, this 20 value. If I take it and I plug in this place, so I will get what? Let me check. 27 minus 0.2 times 220. If I check it, I got 23. So this value I'm going to take from here and cut from here and take on the other page. So I'm digging here now. I hope so you people understanding. So have a look. I'm going to paste here. So this value I have already available from behind, and this is 20. Okay, this is clear. So 20. So basic formula V is equal to U plus 80. Oh, sorry, this is available already. I'm not writing again. So this is this velocity. This velocity V is at B will behave as a U for the onwards. So this behave as a U. This part is very clear. Okay, what is the final velocity? Because ultimately it will come to rest. So our last velocity is 0. And acceleration we just got it, not acceleration, deceleration, negative 0.5. Okay, we need to find what, students? We need to find distance. So let's try to find distance between BC. Okay, so 2AS is equals to V square minus U square. 2 times 2 negative 0.5. S is task. Use V0 and use 23. So if I find it, so well, let me check. 23 square divided by 0.5 and divided by 2, I got a 529 meters. But he's not saying B to C, he's saying A to C. And for your knowledge, if you go back A to C, and distance from A to B already given 2750, 2750. So 2750 is so A to B 2750 distance already given. And if I add, so total distance is turned to be total distance. So 2750 plus 529 meters. And finally, I got 3270. 327, wait a minute, 9, sorry. 1 minute. Yeah, 3279 meters. And I hope so. The concept is very clear and the question is completely over. Question number 5 we have. In this question, what a question. Let's read. Mass A is 3. We can see here. Okay, another n string attached with mass 4 here. All right. And rough plane, contact with rough plane. So plane is a rough. Okay. So it means it has a friction. Okay. And sorry, contact with the rough plane inclined to 30 degree to the horizontal. It means this, you talk about the plane is rough. Okay. And particle B is a contact smooth horizontal. So it means this is a friction is equal to 0, but here friction is not equal to 0. So make sure inclined plane rough and horizontal plane smooth. So this is a rough inclined plane and smooth horizontal. This is a very important thing. Each word is important in mechanics. Okay. And what is further? He says C 5 kilograms. Okay. And both string are taut, passes with pulley. Pulley always smooth in our syllabus. This paragraph is very clear, nothing hard. Okay, please start from breast. So release from breast, so U0. Okay, and move and acceleration is given by him too. Neither A or B is the pulley. So we have to find tensions. Where tensions we have? Let me discuss. There's a 5 into 10, so 50 newtons. So let me zoom for you. You can understand one by one. There's a 50 newtons. Okay, very simple. Tension towards pulley T1 and tension towards pulley T1 is always same. This mass into 4 is a 40 newtons. Okay, and upwards is a R, normal reaction. Okay, second is this is a tension 2 and is also tension 2. So due to pulley, the tension is always towards pulley. And this mass is 3, I got a 30 newtons acting downwards. So this is naturally 30 sine 30. Because no friction is there, so it means we have a R component. So with this R component, okay, I bring it slightly up. This R component, I can make it maybe not in this part, maybe next part. So R is equals to 30 cos 30. I think I have resolved all forces and it contains some marks. So don't I mean be serious in this in all components breaking. So let's try to resolve it. So first of all, I will focus on C. So let's talk about C. Net force is equal to MA. And what read a statement? C moves vertically downwards and with acceleration. So it means this moving downwards. So motion is downwards. So this B will move rightwards. And what about A? A will move upwards. So now one thing is very clear. If motion is rightwards, so here friction is not there. But when you talk about this, if motion upwards, where's the friction? Friction is downwards. Okay, this part is very clear to you. Okay, now an acceleration is given by him, so I can find easily from here. So what about this one? So, and system release, subsequent motion, C move vertically downward, acceleration 2. So let's C part. C part 50 minus tension 1. So 50 minus tension 1 is equal to MA because formula net force is equals to MA. So mass is what? 5 into acceleration 2. I got a 2 from here. So this is a 10 subtract from 50 and T1 becomes 40 newtons. Okay, 40 newtons. Alhamdulillah Rabbil Alameen. This is done. Okay. And let's talk about the other one. Same way I can go for this T2 now. Don't talk about because if friction is there, I will not concentrate. I will focus on a smooth. So let's talk about a B particle. Again, same formula. Net force is equals to MA. This formula I used even here. So, okay, I'm better to just this formula. I'm pasting here also. Okay, otherwise student may ask how he got it. So anyway, this is a B and this is a C. Okay, let me write C here and this is B. Okay. So now we'll talk about this. So T1 minus T2 and so because friction is not there, tension minus tension 2 is equals to MA. Tension 1 I have at 40 minus tension okay, what is mass here? 4 kilogram. So mass is a 4 kilogram. Acceleration is 2. So tension 2 goes there. It comes this side. And I got 40 minus 8 equal tension 2. Alhamdulillah Rabbil Alameen. I believe you people understood well how I got this complete part. So on next page, we have a B part. So he's asking find the coefficient of friction A and the inclined plane. You remember, student, in the previous page, I just showed you this one, but we have to focus especially this diagram. Okay, it's very important. So I just make equation here, and then I will take you on the other side of the page. So when you talk about this one, so what I can say, net force is equals to MA. I write on top slightly because I need a space. So net force is equals to MA. So what is the force? T2 minus friction minus weight component. So I can say T2 minus friction minus weight component, which is 30 sine 30 is equals to MA. is equals to ma. Mass of this three is 3. And acceleration we have 2 already. So I think okay. And now R value is what? This 30 cos 30. R value is this one. So this part I will take on the other side. This part I cut from here and take on the other page. Okay. So I take here. So I'm pasting here. This is done. Okay. Now have a look. Now you know it. T2 is we have it. We have T2. T2 we found previous page 32. So 32. And what is a friction force? We'll go on the other side. And I'm writing rest 30. So 30, 50, 30 is giving 15. And this 6 will go on, will come this side. And friction for, and what is friction formula? Friction value is mu r. And here I'm typing in calculator 32 minus 21. I got 11. And mu is a task, and r is, you know very well, this is a 30 sine 30. And what is r? R is 30 cos 30. And 30 cos 30, basically it is a root 3 by 2. What a 15 root 3, which I'm writing it now here, 15 root 3. So if I type, bring it down, so mu is equals to 11 over 15 root 3. If examiner asks you exact number, so this is our exact answer. But if he asks you, so we can write in 3SF also or exact. 0.423 is our final answer. Sometimes he asks you exact value, exact, then we have to write this as it is. I hope so the point is very clear. When the system has been in motion for 1.5 seconds, the string breaks, and the string attached with the A is breaks. Okay. All right. The total distance by A travels up the plane for the instant when the system is released, come from the rest to, and it come to rest. So we have three conditions. Okay, look at now. This is inclined plane, and the particle A is moving in through two conditions. One here and one further moves like this. Okay, two conditions move. So it is starting here. Is starting from here, and you know it very well. What is speed? U is 0. Okay, and in this acceleration is 2. We know it already. We have done it. Okay, we need to find this because time is when string breaks 1.2. So string breaks, so it will move with this acceleration till 1.5 second. After 1.5 second, string will break, then it will move. This is called inertia motion. This is called inertia motion. Okay, so last velocity is here 0. You know it very well, but this acceleration we need to find. Why need to find? Why cannot these two be same? Because string is broken, string is cut, and string is break. So that is why this acceleration we cannot use this one. But interesting part, this final velocity of this stage will become starting velocity of this stage. I repeat my words, the ending velocity of this stage is actually starting velocity of this stage. So let's find out the final velocity. So before string breaks, before breaks. So what is the formula? V is equal to U plus AT. And V and U is 0, and acceleration is 2, and time is 1.5. So I got a 3 meter per second. It means very clear. So this is the last velocity 3, which becomes inertia motion. This velocity is my last velocity here 3 will become U is equal to 3. So now we have data available here. This is what is my job to find S is for. Our job is to find total distance traveled from the total. So this distance and that. So this distance we need to find as well. So let's try to find distance also before string breaks. So 2as is equals to v square minus u square, and 2 times 2 acceleration 2s is a job to find last velocity 3, u is 0. And if I find it 9 over 4, so I'm getting 904 meters. So just string breaks distance 9.4. And now this distance is task left behind. But with interesting part, when a particle is traveling upwards, this is called tension. This is called mg sine theta. And this is called friction. So basically tension minus friction minus mg sine theta is equals to ma. But interesting part, when string breaks, this tension goes 0. So this becomes 0. So I'm putting 0, and friction value we have already. Friction value will not change. And friction value, basically we have it. This is actually friction, and friction value is same, which I'm just, let me check again. 32 minus 21 is 11. So friction is 11. Already we have it, 11. And mass of the particle is what? Is a 3. So this 30 sine 30 and equal to 3 times to a. And from here I can get acceleration. So negative 11, negative 15, and divided by 3. And I got acceleration becomes negative 26 over 3. So this is actually this motion. Now I want to find it distance travel as well. So let's define distance. So what is the data? Data is very clear, available. U0, U is 3. Data is available. Let me write all data. U is 3. Top last velocity is 0. And acceleration I got just now 26 by 3. And S1 is this. S2 is the other one. I'm counting. I'm calculating, sorry. So 2AS is equal to V square minus U square. 2 times to negative 26 by 3. S is 3. Sorry, S is a job to find. Last velocity is 0. This is a 3. So this, when I find it, 9 divided by 2 divided by 26 into 3. And if I calculate, I get the answer 27 over 52. So S2 coming 57, 27 over 52. So total distance is 904 plus 27 over 52. So if I check it, so it turns to be 36 over 13, and answer finally coming with us 2.77 meters. I hope so. The concept is very clear, and this question is over. Question number 6, we have particle P moves straight line, passes through point A, and time is 0. The velocity is given by formula here. Find maximum velocity. So make sure, student, whenever maximum or minimum velocity comes, any, or even constant velocity, so always acceleration is equal to 0. But we have a 3-level, students, always you must familiar. Displacement, if I differentiate with respect to time, d over dt, we get a velocity. If I differentiate again velocity with respect to time, d over dt, I will get acceleration. And if I want to come down, I will integrate with respect to time. And if I want to come down, velocity displacement, I will integrate. Currently, we are on a level of velocity and we are looking first for acceleration. So I'm going to differentiate. So what is dv by dt? I'm writing dv over dt. Power 3 by 2 will come down, multiply with this, and 1 reduce. When I reduce 1, I got to have, don't forget, students, base derivative, which is 2 and 0. So 2 plus 0 is 2. This 2 come from here. And negative. What about this? 2 2s are 40. So Alhamdulillah Rabbil Alameen. These 2 cancel out, and I got finally 3 root of 2t plus 1 and negative 40. And this is basically we got acceleration. And I'm going to put acceleration is equals to 0. When I plug in 0, 3 root of 2t plus 1 and negative 40 is equals to 0. 40 goes on other side, and I got a 3 root of 2t. All right, make it a little bit down. Okay, 2t plus 1 equal to 40. So this 2 cancel, sorry. Okay, squaring both sides, we got to get rid of the root. And root gone. So 2t plus 1, because square of 3 and square of root. So here I got 16t to power 2. 9 2s are 18t and plus 9. Rearrange 16t to power 2, negative 18t and negative 9 is equal to 0. I can factorize or quadratic formula. So b square minus 4ac and divided by 2a. So what is so let's see what answers I'm getting. Okay. So my first answer is coming with me is 3 over 2. Second answer, I'm getting negative 308, which I will ignore because the time. Okay, but he was asking maximum. So that value of time I will plug in back in equation, which is here what? Velocity equal to 2t plus 1 to power 3 by 2 and negative 2t to power 2. So this equation, I need it down. I need down. Okay. I'm going to plug in here. So when I plug in here, students, so it means 2 times 2, 3 by 2, plus 1 to power 3 by 2, negative 2 times 2, 3 by 2, and power 2. So final answer, because he asking, this is called Vmax, maximum velocity. So students, I'm going to plug in. This is 2 to cancel out. I got a 3 plus 1, 4. 4 to power 3 by 2 and minus 2 times 2, 9 divided by 4. My answers come with me 3.5 meter per second. Alhamdulillah Rabbil Alameen. I hope so. This part is clear. So part A is done. So students, part B. What is asking? It is given that the particle is instead of 0, the particle velocity is positive, and distance p to find instant when p is moving the maximum velocity. So this is we have it, and you know, students, we have 3 levels, as I said on previous page. So what I said you that whenever we are displacement, velocity, and acceleration. So I am right now on velocity and I need to find distance. So I will come down, I will integrate. So let's start. So distance is equals to integral sign, and this complete equation I'm going to, I think better to paste here, and there's no need, and dt. And limit is very interesting, 0 to 1.5. You ask why, sir? What is the logic? Or what is the logic behind? Because he said that find out the starting from A and till what? Till what? Instant when P is reaching maximum velocity. And maximum velocity, if we go back, in maximum velocity, we plug in acceleration 0, and maximum velocity time is 3 by 2. So this 3 by 2 I use as a reference, 3.3 by 2 or 1.5, same meanings. Now, what to do? Integration criteria, increase the power by 1. So 5 by 2 over 5 by 2 into 2. These two come from base derivative, and increase the power by 1 divided by same. Sometimes we do a C, or sometimes we can do without C when limits are confirmed. When limits are confirmed, then we go with the, when limits are not confirmed, then we go for the plus C. But here limits are confirmed. So these two to cancel out. I can plug in upper limit. First, I plug in 1.5 in each t value. So I'm going to plug in. So let's start. 2 times 2, 1.5 minus 1 to power 5 by 2 and divided by 5, negative, and 1.5 to power 3 by 3. This is done, upper limit done, and minus lower limit. What is lower limit? When I plug in 0 here, I get a 1 to power something by 5. So I get a 1 over 5. When I plug in 0 here, it goes away. So I think idea is very clear. Now it's just typing in calculator, and I'm typing it 3 by 2, 1.5, sorry. So 2 times 2, 1.5 is a 3, and minus 1, 2, and 2 to power 5 over 2. And divided by 5 and minus in fraction 2 times 2, 1.5 to power 3, and denominator we have a 3. So this part, okay, and 1 minute please, 1 minute, 1 minute, 1 minute. Let me check again. Oh, there's a plus. Sorry, it's a plus, not a minus. By mistake, I wrote minus. That is the reason I got a different answer. Okay, once again, I check it. 2 into 1.5 plus 1 to power 5 by 2 and divided by 5. And negative in fraction 2 into 1.5 to power 3 and divided by 3. And this I got a 83 over 20, and minus 105. So minus 1 over 5, and I'm getting here 79 over 20, which basically equals to what? Which basically with 3.95 meter distance. So Alhamdulillah Rabbil Alameen, I believe you people understanding very well. Question number 7, particle P of mass 3 kilogram is projected with a speed of 8 up. The slope of rough inclined plane angle 30 horizontal. So situation is this. Okay, this situation we have. Okay, so then he said P is projected from the point A. So this is A, angle 30 degree, and come to rest at B on the point. It means, let's say B is here. P then slides, and I think he's been given speed of, it is 8. So here the particle's thrown speed at A is 8 and thrown up. Thrown up. Okay, thrown means applied force gone. How I know that? Reason, when you threw the particle and it goes away from your hand, applied force becomes 0. And work done by applied force is common sense 0. Okay. Now he's saying further, when P on B then slides back down the plane, it means go, what is the planning? It will go reach on the top and then start coming down. Okay. So this point is very clear. Okay, this clear point. Okay. And the coefficient friction is given this one. So mu is given by him is 1 over 12 root 3. Find using energy method, okay, and find the speed of the P when it returns to back to O. So first speed while going upward, we know it, but coming downwards, we don't know. And the particle will stop here on the top because he said at rest. So last velocity at B is equals to 0. And thing is, this is called height. And this distance we don't know. First of all, we need this distance. So first I use SOHCAHTOA opposite by hypotenuse is equals to is equals to sine theta, sine 30. And sine 30 is a half, so h is equals to x goes there. We got a half x. Okay. Now I'm going to apply magic formula. What is the magic formula? What is the friction force formula? F is equal to mu r. Mu is given, r we can find it. How come? When a particle is placed here, look, I show you, and this is r. R is this way, and what is this component? This is a mg, what is called mg cos. So what is the mass? 3. And what is the weight? 330. So 30 cos 30. And when I check it, so this is R value. So I'm going to plug in it here. And mu comes from the top. So F is equals to 1 over 12 root 3 into 30 cos 30. And what is the 30 cos 30? If I check in calculator, so it gives us 15 root 3. 15 root 3. And 15 root 3 multiplied with the root 3 and divided by 12. And we get the answer 15 over 4. So frictional force is coming 15 over 4. Okay, newtons. Now, what is a work done by friction force? Work done by friction force, small f into d. And d, I don't know x. So I can say this is coming with us 15 over 4 times 2 x. So I think now we are eligible to apply a formula. We have a okay. What is basic formula? We have magic formula. We can write work done by applied force, work done by frictional force, kinetic energy plus potential energy on a top point, that is a ending point P, and Ke plus potential energy starting point. Starting point is A. So we need what is potential energy at A, that is 0. So this is no need. Okay, and kinetic energy on a B is 0. Sorry, Ke, not P. So this is also 0. So both are zeros. This is 0 and this is 0. So I need two things. Potential energy at B, and what is the formula? mgh. What is the mass? 3. G10. H is how much? H is, I just got it, half x. And I 2 5s are 5, 15. So I got a 15x. Okay, what is a kinetic energy at A? Half mv square. Half mv square. Mass is a 3, and speed is a 8. So I think clear. So at 64 divided by 2, 32. 32 into 3, it gives 96. So I think I have all values, so I'm going to plug in. Okay, let's start now. This value is 0 because of no applied force. This value, I got it 15 over 4 times 2x. Kinetic energy at B is on the peak is 0. Okay, and potential energy at a B, we have it, and that is a 15x. Kinetic energy at A is 96. Negative. Potential energy at is 0, so because is a ground level. So if I find it, 96 go left hand side, 15x and plus 15 over 4 times 2x. So 15 plus 15 divided by 4, we got a 96 is equal to 75 upon 4 times 2x. So 96 divided by the answer, and I got a distance 128 by 25 meters. So this is a distance I think you understood well, but we game is not finished. This is a distance while traveling upwards. Now we find same situation, but it's coming downwards. So we can apply same condition. So have a look now. So same data, I have it. Same data, we have it. I think we can apply. Best idea, I will take whole diagram again, because not even this. Even I hope so you understand. I will take this also. And what about the other values? Let me check. Mass, potential energy not change, kinetic energy will change. Yes. Okay. So I'm going to copy this whole thing, and I think so better to copy this full thing. Okay. Which I don't need, I will erase. So check in, and I'm going to shift to next page. Next page. Okay. So have a look now. I'm going to paste here what I have taken a screenshot from back. Okay. Now, what is the thing is, students, now is particles coming from top to down. So now velocity is changed. So top velocity is starting from rest. So this velocity at B is equals to 0. But velocity at A, I need to find it. And x distance, we have it now. X distance we have now. We have x distance. Okay. X distance we have. And this time particle is not traveling upward, it is coming downwards. Okay. And distance we have it, S is equals to 128 over 25. This part is very clear. Now everything remains same. So this H remains same, but I think we can find H easily now. So what is H? We can say here half of it. So multiply by 1 over 2. Okay. I got a height turns to be 64 over 25. How come? So this, when I kept here, I got a height. Okay, clear. So this is clear. And friction force I can find even. How friction force I can find it? If I plug in the x value, because x value we are confident now. This value plug in it here. So 15 divided by 4 times to 128 divided by 25. And I got a 19.2. I'm getting a 19.2. So 19.2. So, and what is the potential energy, students? Potential energy, this x will replace. So 15 into 128 divided by 25. And I'm getting here 70, 76.8. This is also clear. Now I will just values plug in and question over. This is 0, we know it. Work done by friction force, yes, we know it, 19.2. Kinetic energy at a B, we know 0 because starting from rest. Potential energy at B, I can find it. I think so. We have it. We have already MGH. So we have it already 76.8. Kinetic energy at A is my job. So I'm writing here half mv square. So half mv square. Mass is a 3, I think so. Yes, 3. Mass is a 3. 3m half mv square. V of A particle. Negative into positive give us negative. Potential energy at A is 0. I think point is very clear. So I bring this whole here. I got a 3 over 2 times 2 VA square and 76.8 and plus 19.2. Now I'm going to finish the question, inshallah. Plus 19.2. I got a 96 here. And 3 up and, 2 up and 3 down. And I got velocity of the A. So multiply by 2 divided by 3. And I got a velocity of A square, 64. 64. And velocity of A becomes with us 8. So I hope so. The point is very clear. Okay, this time because particle is traveling from top to down, okay, top to down. So ending point is A. So we write A here and we write B in this point. And rest values are same, which I found just now. Work done by applied force is 0. You can see on top. Work done by friction force is 19.2. And kinetic energy at A is we need to find. So don't take this. This is from the previous part. Even you can erase it, no issue at all. Even you can erase this. Or half mv square. So that I'm writing here 3 by 2 VA square. What is potential energy? Because ground level is 0. So this is because height is 0. And kinetic energy at B is 0 because speed is 0. And negative into positive, negative, and potential energy at B we have already 76.8. And now bring this on the other side. 76.8 negative 19.2. 3 by 2 times 2 VA whole square. Now I make it VA subject and this 2 multiply and 3 divide. So what I get finally? So 76.8 minus 19.2. I'm getting here 57.6. And now 2 multiply up and 3 divide. So 57.6 times to 2 divided by 3. And I get it what? 38.4. Take a root of this answer and I got a 6.196. After rounding, I got velocity 6.20 or 2. That's it. So Alhamdulillah Rabbil Alameen. I hope so. The concept is very clear and the paper is completely over. Best of luck for exam.